that initially got my CDO heightened, which for those that don't know, CDO is a little like OCD, only you feel compelled to put the letters in alphabetical order.
Oh, man. This is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm DonnFelker.
And I'm KaushikGopal.
Welcome to the show.
You know who's amazing? You're amazing. You're an Android developer and you're upping your game by listening to podcasts, especially podcasts about Android development in your downtime. Companies are desperate to recruit developers like you. But searching for a new job can be stressful and scary, and you want to spend more time coding, not dealing with any more human beings than you already have to. So where do you go to take advantage of this unique position that you find yourself in? Hire.com. So after completing one simple application, the top employers in your area apply to hire you. So you receive personalized interview requests and upfront salary information so you can make an informed decision about which opportunities you want to pursue. Now, usually Hire.com's customers get a $1,000 hiring bonus, but as a listener of Fragmented, by signing up with the show's link, which is hire.com/fragmented, you get double the bonus. So that's $2,000. So if you're looking for a job, use Hired, and please do use our special link. They'll know that you came from us, and that'll help support the show. Thanks again to Hire.com for sponsoring today's show.
So, Kaushik, you went to Google I.O., didn't you?
I did go to Google I.O.
And from what I remember, there was some pretty cool stuff that was announced. And I think the biggest thing, which has kind of been discussed around the circles lately, is a new layout has been released at Google I.O. when we've been getting these preview drops through Android Studio and so forth. Mm-hmm. Do you know of anybody who might be able to kind of fill us in on what this layout is or anything like that?
Funny you should ask. So usually, even like from my early days of Android development, what I usually do when I try to find anything view related, if there's something I'm trying to learn, one of the first blogs that I used to hit is this one called Styling Android. Have you heard of it?
Yeah, it's great. Love it.
The chap who runs that is also a really good friend of the show and a very nice human being. So we thought, hey, he's running this amazing Constraint Layout series now, so we should definitely get Mark to give us a few tips and tell us what's about with Constraint Layout.
Mark, welcome to the show.
Welcome to the show, Mark.
Thank you. It's very nice to be here.
So this is actually a very special episode for us because for both Don and me, this is our 50th episode, and so we're thrilled to have you on this episode.
I'm honored to be here, honored to be part of such a landmark episode.
So, Mark, for folks that maybe haven't read your blog, and if you haven't read Mark's blog, are you under a rock? That's my first question. But if for folks that haven't read your blog and who are not familiar with who you are, can you explain a little bit about who you are, kind of your involvement in Android, maybe a little bit about your blog and everything in general, just so folks can have an understanding of a little bit about you?
Sure. I'm currently a freelance Android developer. Been developing Android for about 6 years now. I started off way back in the time I joined T-Mobile in the UK, and T-Mobile were very into Android early on. They launched the G1 over here. They were the first operator in the UK to launch an Android device, and so I was in with Android from the early stages, and quite early on, I sort of saw that there was lots of people writing about Android, but there was very little in the way of getting information about how to get the UI working and get it looking good. And so I decided to start writing a blog, and here we are 5 years on. I had the 5th anniversary of the first post earlier this year. So,
oh, wow. Congratulations.
Yeah. And in that time, I've only had a very brief period where I wasn't able to post for some contractual reasons over a job I was doing. But other than that, I've been uninterrupted. I don't take breaks for holidays or anything. So it's a pretty grueling schedule, but one post a week.
What got you started on styling Android? What triggered that very first blog post?
It was actually a drunken conversation at a Christmas party.
All good ideas start like that, I've heard.
This is going to be a good story. Here we go.
A guy I worked with at the time, Darren Steele, he was always coming to me for help on stuff, particularly UI stuff. And sort of after a few beers at the T-Mobile Christmas party, he said, you should write a blog. And my initial reaction was, no, I wouldn't know where to start. And but the seed was planted, and then it sort of slowly germinated, and about 3 months later, the first post went live.
That's awesome. So styling Android is, like I said, one of like the biggest resources that we use. And right now, I think you just wrapped up this series on Constraint Layout, right?
Yeah, it's proven to be quite a lengthy series. It kept growing and growing because it's such a complex and interesting subject, and I don't think for one moment that will be the last I write on Constraint Layout, because already there's things that Nicholas Raud, one of the developers on there, is saying is works in progress that are coming soon that are going to add even more functionality to it. So there's still more to come. As I say, it's grown into a little bit of a monster, but more because I kept finding more stuff to write. So it's very much a case of some subjects you can cover quite quickly, but others where there's lots of subtlety and different things working together, and lots of different aspects to it. It lends itself to a longer series of posts, so you can cover things in a bit more depth.
That makes sense. But I think one of the advantages is like your posts, even though you have like an 8-post series going on, it isn't super lengthy. I think it's just you hit the perfect sweet spot. So like I read one post, I absorb the content, then I'm ready for the next. So even though it's 8 parts, it's perfect. Like especially people interested in the constraint layout can really punch through that stuff. So okay, let's start off. What exactly is the constraint layout? I mean, Android already has a bunch of layouts, right? So could you tell us what exactly, like for someone who's never heard about this new thing that was announced in I/O, could you give us like a quick sort of like gist or summary?
The main motivation behind it is the existing layouts that we have for Android are all fairly mature, but because they're fairly mature, I think we've discovered some of the issues with them. There's quite a few performance related issues with both weighted linear layouts and relative layouts, with lots of advice coming from Google not to use them. And it's all well and good to say, well, don't use them, but what if there's no alternative? What if they are the best solution currently available to us? You really are forced to use them. And I think that's really been the motivation for Constraint Layout to act as a top level layout. So for a long time, the advice for Google has been don't use relatively layouts at the top of a view hierarchy, and don't nest linear layouts with weights, because in both cases, the number of measurement passes for each level of nesting is going to grow exponentially, and that becomes expensive. The primary motivation behind Constraint Layout, and I believe what's really encouraged the development of it initially, is to try and address some of these performance issues, try and look at the use cases that many developers are having to use these older mechanisms to use that we're being advised against, and try and provide alternatives for those. So that's the primary reason for Constraint Layout, to provide us a different set of tools that's better geared to some of the more complex layouts we're doing than maybe we did 5 years ago.
So we have Constraint Layout, which is, I see the letter C and L, so I think Constraint Layout. But then my mind kind of plays tricks on me, and I think Coordinator Layout. What are the differences between these two? I mean, is it not to be confused with the Coordinator Layout, or does it work together, or what are your thoughts on that?
It's a completely different thing to Coordinator Layout. Coordinator Layout is designed to allow multiple children to coordinate together. So for things like when you have a snack bar, for example, that can appear at given points in your layout, and it can make your fab move and things like that. That's made possible because of the marshalling that coordinator layout does between these various child components. So it's much more about getting siblings to cooperate rather than necessarily being a layout in the true sense of the word. A layout is primarily for the positioning and sizing of views relative to the parent and each other. And so relative layout, linear layout, to a degree, some of the table forms of layouts all do that, whereas coordinator layout isn't necessarily down to the positioning. It's more interaction between controls. So I would argue that it's almost not a layout in the true sense of the word because it's doing something slightly different.
And I remember in your post, in the series of posts that you have, you made a very good point about like defining what layouts should mean to us, right? You said layouts are view groups that basically measure the size and position of themselves. So taking that definition, I think coordinator layout, like you rightly said, doesn't actually seem to be an actual layout, right? It's more like something that helps with the animations and the interactions between these views.
Absolutely. And constraint layout is very much a traditional layout in the true sense of the word. And to properly appreciate that, it's worth understanding how layouts actually work. You basically have three phases to a layout. You have the measurement phase where all of the children of that layout are measured. You then have the layout phase, which is where they're all positioned both relative to each other and based on the parameters of the layout itself. So in linear layout, they're flowed either in a horizontal or vertical direction. In relative layout, they're positioned relative to each other. And in constraint layout, they're positioned relative to the constraints that constraint layout defines. So they're firstly measured, then positioned, and then finally they're drawn. So when you come to draw them, it's not doing any calculations about what should be positioned where. And so this is why it's important to understand this, because when you start animating stuff, you're not going to want to do all of those phases again. What you need to do is just perform the draw phase and subtly change things so that you can draw frames as quickly as possible. Otherwise, you're going to get a really janky animation. And constraint layout will work perfectly well with all the property animations and everything else you've used in the past because it's working exactly like any other layout. All of its work is done by the time we come to draw, and it's at the draw phase where animations are applied. So you really don't need to worry about whether you can animate things cleanly or not, because it's just a layout. It's a view group, and it behaves like any other view group.
So I assume that this makes things in the performance category a lot better because there's not all these multiple passes that have to be done, correct? Because this has already been, everything's been measured and we know the position of these views already. Is that the correct assumption?
Yeah. I mean, you shouldn't be trying to animate your layouts as such anyway. Because if you change something in the layout itself, you've got to perform all these passes again. So you do that once, and then you just move individual views or change alphas and things like that when you come to animate. If you were to try and do the full measure and layout pass for each animation frame, it's just going to kill things. But again, that's nothing specific to constraint layout. That's just how view groups work.
When we get these complex designs from our designers, which we always do get, does it automatically mean that I should maybe evaluate constraint layout right out of the box, or should I use the existing tools that I have? For example, I maybe get a sketch file or a Photoshop file from a designer that has some, a list, and inside the list it has a bunch of indented things and icons and all over the place. And I personally end up using a bunch of weighted linear layouts, which I know I'll be probably cooked on a steak for, but it just seems to work. And that's what a lot of people have ended up using just because those are simple things. Does constraint layout make those things easier to work with, and is it more performant? That's
the idea. And in terms of performance, the latest drop, which is Alpha 4 at the moment, that's had a whole heap of performance improvements. For Alpha 3, Wolfram Rittmeyer wrote a blog post and in which he covered a load of performance stuff and found that constraint layout really wasn't as performant as it was claiming to be. But since then, there have been a whole heap of improvements, and Wolfram has since mentioned that he's seen a huge performance improvement in Alpha 4. I think he mentioned sort of a factor of 2 to 3 in terms of the measure and layout performance.
Oh, wow.
I had a quick follow-up point. So like one question I've always had is, does constraint layout just extend like a view group? And like you answered that, so basically it's just like any other view group, right? Is that assumption correct?
Absolutely. It's a black box in terms of how everything else works. You don't need to think any differently about putting a constraint layout in any view hierarchy. But as I mentioned earlier, it's being specifically designed to be a good top level layout. So once it's stable enough to be using full time, I think the idea is that you don't think about at the top level, do I use a linear layout or a relative layout? You think about the top level, you just use constraint layout.
Gotcha.
And that's one very interesting point you say specifically about the top level, right? Because I remember one point that they brought up with relative layouts is the reason it's expensive, and it's especially more expensive if you have it at the root or like at the top layer. This is because I think like with a relative layout, it's almost always guaranteed that you would have 2 passes. As you have a deeper hierarchy, if you have your relative layout right at the top, that basically means it just like at that point it goes like exponentially higher, right? So that's one reason they say relative layouts specifically at the root is like really costly. You don't want to be doing that.
Yeah, it's for example with weighted linear layouts, when you do the measurement pass, it has to measure each child twice, because it has to do a second pass once it knows to divide up the weight. So firstly, it measures them all to see how big they actually are. Then it needs to divide up the remaining space, so it needs to do a second measurement. On its own, it's not so much of a problem. But then when you put another one inside it, it's actually measuring the inner linear layout twice, which itself is performing 2 measurement passes. So in other words, the inner one then does 4 measurement passes because it's doing 2 measurement passes and its parent is measuring it twice. And then if you put another one inside of that, it's doubling again, so you're going up to 8 measurement passes.
Oh, wow.
So they start getting quite heavy, and that's really why the advice is don't nest these things, because they will kill your layout performance.
So let's dive into actually using constraint layout. Like, how does one actually use constraint layout? Can you explain to our listeners? You made mention of a point where one of the reasons animations work is like it's only the translation properties inside that change. It's not necessarily the absolute position attributes, which is why another layout pass doesn't need to be made. Could you tell us a little more about that, like the left, right, top positions? Because I think that's like super important for us to understand, right?
Yeah, probably the one of the key things to look at. And if you dive into the source code for Vue, there's a really interesting couple of methods there. You've got set X and set translation X. And if you actually look at the source from those, you cannot call set X on the code. It will actually get applied to translation X, not the X value. And so you have these 2 values. You have the X position, which is the offset in the X axis, and you have the translation X. The X value is actually what gets calculated during the layout pass. So that is done by the layout manager, and you don't want to touch it because the layout manager is purely responsible for that. And as I say, if you look at the source, it won't let you.
And that's the costly one, right? Like that's the one you don't want to keep changing frequently.
Well, that's the one that isn't your responsibility to touch, and that's why you're not allowed to. But what you can touch is the translation X. That you can do whatever you want with. That's the cheap one to tinker with. To change that doesn't require a layout pass. Whereas to change the X value, which if you think when you're positioning 2 child views relative to each other, if you change the X value of one, then the X value of the other should change with it. That's why you need to perform the full layout pass again. But if you perform the translation X on one of those views, it shouldn't affect the other. So it's just moving it relative to its own calculated position. And that's why you have these 2 values. One affects could affect other views depending on what type of parent layout they're in, but the other one just affects that view itself. And it's the one that just affects that view is the one that you should be animating.
And so with that in mind, can you tell us what anchor points are now? Because that's apparently an important concept with the constraint layout, right?
Yep. Any view has a series of anchor points defined as far as constraint layout is concerned. Even the constraint layout itself has a top, bottom, left, and right anchor point. And an anchor point is literally a reference where you can link two views together. So if you drop a child view into a constraint layout, and then you can position that child relative to the anchor points of either the parent constraint layout or any of its siblings within the constraint layout. And so these anchor points are defined on all the views, including the parent, and allow you to create these reference points. And these reference points or anchors are what enable you to create constraints. And effectively, a constraint is a relationship between the anchor points or two anchor points of two views. So when I said you can drop a child view in, you create a constraint between an anchor point on the child view and an anchor point on the parent. And that way you can align a child view to the top of the parent. And then you could drop in another child view and you could create a constraint between an anchor view on the second child view and the first child view. So then you're getting relative layout-like behavior.
And these anchor points refer to those left, right, and top positions that we talked about earlier, or are they to the translation X, Y, and...
No, they're to those calculated positions. And for text-based views, you have an additional one as well, which is the baseline. So that's subtly different to the left, right, top, and bottom, which are the bounds of the view. The baseline is the text baseline. So you can actually align two text views by baseline rather than necessarily the outer bounds of the view itself.
Oh, so they've added some intelligence to sort of pick the most reliable attribute of that view, and then they work the constraints out of those.
Not really. You can, there are some automated constraint generation tools in the visual editor, but you can create these yourself. So all you do is you click on, the anchor point from one view and you can drag it to an anchor point of another view and it will create the constraint for you. But then you do have this auto constraint mode in the visual editor where it will try and infer constraints from where you drop the child.
That's the one I keep using. I go bananas on that one. I'm like, let it just figure it for me. I don't want to drop it, just position it and boom, keep inferring constraints and thumbs up.
Well, that's actually quite a good tip for learning how constraints work is turn that off and create them manually. So you learn how these constraints work. And then you can understand what the auto constraint inference is doing for you. And that way, if you need to tweak it, you know what they actually mean.
Now, there's also, I noticed, I think it was in part 4 of your Constraint Layout series, after talking about various anchor points and kind of creating them and so forth, you mentioned something known as a bias, and you use the analogy of like two springs to help set the bias for a view. Can you talk about bias? What is it? Why I would use it, and maybe how it's important?
It's used for you can actually fine tune the positioning. Let's go back to the example where we've just dropped a child view in, and we've just manually created a constraint between the top of the view and the top of the parent. If we then create a second constraint from the bottom of the child view to the bottom of the parent, depending on the layout height that we've set, if we've still got that set to wrap content, then it's not going to expand to the size of the parent because that's in direct conflict with the wrap content. But what it will do is it will actually center it within the parent. The reason that it centers it is because you have these two constraints and they each carry equal value when it comes to calculate the position. Well, what we can then do is we can set a bias on those constraints so that it actually is pulled more towards the top And it's effectively a percentage. So you can just give a percentage value and it will position either closer to the top or closer to the bottom, depending on the bias.
Okay, so that bias helps determine that that tension is what you're saying.
Yeah. So if you imagine it as two strings, springs even.
Yeah, springs, yeah.
If you imagine that the top spring is much more powerful than the bottom spring, it's actually going to pull. It's not going to pull it completely to the top, but it's going to pull it closer to the top than the weaker bottom spring. And that's effectively what the bias does for you. It allows you to just tweak those strengths so you can control quite precisely where in the parent that particular view will be positioned. And because you're not working in pixels or DPs, it's just a percentage of the parent. It's really going to translate well across different device sizes and pixel densities and even orientations.
So this kind of reminds me of the layout weight in linear layout and the percent layout as well. So, I mean, I guess there's some correlation that we could draw between those two to kind of help understand that concept. Would you agree?
Yep. They're similar, but not quite the same, because you have some subtleties with layout weight. And this is actually something that I had a conversation on Android Study Group with Nicholas Rod yesterday about some things that are coming. Whether or not they're going to be in version 1.0 or they're still going to be a work in progress, he wasn't sure. But one thing that's missing that weights do give you is if you set one of those views to gone, then the other views will expand according to their weights, whereas that's not quite there with Constraint Layout yet. But there are some things called chains that are on the way that it's more of an abstract concept by the sounds of things, and I didn't quite understand how they work, but they sound as though they're going to fill that gap.
Oh, that's a good point to mention. Yeah. Because I mean, in most of the code that I write these days, like relying on that view.gone and view.visible and invisible, like, yeah, a lot of logic is based on that, right? The UX interactions are very heavily reliant on that.
Yeah. And there are other tricks that you can use to simulate weighted layouts. So you have these things called guidelines, which these are really powerful things. And anyone that's familiar with graphic design or even page design tools will probably be familiar with the concept of a guideline, which is it's a non-visual component. So it's not something that gets seen by the user, but you use it in the design phase to allow you to position things correctly. And a guideline is exactly that. It's basically an invisible view that when it comes to the layout pass, it actually gets its visibility set to view gone, but you can still position things relative to it. So it won't render anything, but you can position things relative to it. And then you can position these guidelines either a fixed offset in DP or a percentage of the parent. So they are pretty powerful things as well. But once again, they don't give you the full linear layout weights behavior because you're positioning things relative to them rather than views relative to each other, which is what the weights are doing. You make one view gone and the others should fill in the space.
Now, we've talked a lot about how we build these constraints, the biases, the guidelines, and all this is all very visual. And this is all done with a visual designer, a visual editor, as you mentioned in your blog posts. Now, what does the XML look like? Is this something that we should be reading, or should we be worried about reading the XML or trying to hand edit it? What do you think?
Personally, I've been playing with it. There's a lot of attributes, but actually most of them are pretty easy to understand because all of the constraints are created as attributes and they take the form of something like constraint, start anchor point, end anchor point. So you can sort of read it and understand what the constraint's doing. And actually writing them isn't that tricky either. So it's worth understanding, I think, particularly if you're doing code review, because unless you're actually checking out someone's pull request and looking at it inside Android Studio, you're not going to have the benefit of the visual editor while you're trying to review this stuff. But as I say, it's not that tricky. It's made a little noisier because the visual editor puts quite a lot of tools annotations in, which for those people that aren't familiar with the tools namespace in XML layouts, it's a mechanism where you can put in stuff that's relevant at design time. So, for example, instead of using the text attribute in the Android namespace, which would set the text on a text view, if you use the tools namespace, so you say tools:text, that will set the text on a text view. It will appear with that text when you look at it in the preview in Android Studio, but it's not actually setting anything. They get stripped out during the build. And so at runtime, there will be no text set on that particular text view. That will stop lint warnings about you should really be using a string resource here. So if you just want to see how it's going to look by using the preview in Android Studio, use the tools namespace so you can preview it without having to fix lint warnings. But that tools namespace is used quite heavily by Constraint Layout because it puts in hints for the visual editor to know how to position stuff. So it's stuff that isn't relevant, so will get stripped out during the build, but it does add noise when you're trying to review layouts containing Constraint Layout. But one tip I found quite useful for doing that is it takes a little bit of setting up. But in Android Studio and IntelliJ IDEA, you have a mechanism for code formatting. You can apply custom code formats and you can set up your code formats. And there are ways that you can apply this to XML files as well. And you can set up a series of formats that will control the order of your attributes. So if you, at the very simple level, if you just group by namespace, it will group all the Android namespace attributes together, the ones prefixed with Android : if you have any app ones, they will be grouped together. And therefore, if you have any tools ones, they will be grouped together. I usually move those to the bottom because they are the ones that can be noisy, that really don't have any bearing on what's going to happen on when you run it on a device. You can actually ignore them. And that's just a good practice for any pull request, but it's even more valuable when you're dealing with Constraint Layout.
That's a good point. Speaking about the visual editor, one interesting point that you made is, and they talked about this as well, and I didn't quite understand why they gave it so much importance during the keynote. They mentioned that they're like very smooth and slick animations, and some of those animations in the visual editor are actually pretty slow. And I didn't quite understand it, but then when I read your blog post, like you called out that some of those slower animations were intentional.
Yeah, absolutely. That was something that jumped out at me when I saw the initial demos at Google I/O, that as they were dropping these views into the constraint layout in the visual editor, you suddenly got these what seemed glacially slow animations going on. And, you know, that initially got my CDO heightened, which for those that don't know, CDO is a little like OCD, only you feel compelled to put the letters in alphabetical order.
Oh, that's amazing.
Oh, man. That's great, Mark.
But yeah, that leapt out at me at the time, that it just seemed that, normally you never want animations to outstay their welcome, because if you keep users waiting, they get frustrated. And this is what this felt like. But actually understanding there is actually a strong purpose behind it, is that when you have these auto infer constraints, so you just drop a view and it will try and work out what the constraints are. It runs this quite slow animation. And if you're happy with it, you can just ignore it. It's actually made those constraints. It's just giving you a chance to change your mind. And that's why they're slow. You get a couple of seconds grace to say, actually, no, I don't like where I dropped that. So you can start moving it again, and it just resets the timer and will then start again when you next drop. If you do nothing, you can actually just carry on working and completely ignore them, and it won't change anything. They will just happen automatically. But if you decide, no, I'm not quite happy with that, you just get which most of the time you're going to drop something and you're either going to know pretty much within a second or two whether it's right or not. And if it's not, you've got that chance to change it.
So we've been talking a lot about and hyping up constraint layout from top to bottom. But as with anything in development, there's pluses and minuses to everything. And one of the weird things I noticed while reading through your series was that there is no match parent in coordinator layout. There's something known as any size. Can you talk a little bit about that?
Yeah, basically, because of how constraint layout works, match parent is no longer really a valid thing. It's a subtle difference, but traditionally with match parent, it does exactly what it suggests. It's going to size a child so that its size equals that of the parent. But with constraint layout, it's a little subtler than that, because if you start positioning two text views so that the first one is aligned to the left-hand edge of the parent, and then the second one is aligned to the right-hand, its left edge is aligned to the right edge of the first child, you're going to effectively reproduce the behavior of a horizontal linear layout. But if you set one of those child widths to match parent, that's going to screw a load of stuff up, because how does it know? Should it be expanding to fit the size? So it's more, you don't have a match parent, you have an expand to fit the size. And that's what any size is. And that behaves quite similarly to the layout width or the layout height when you're using a weighted linear layout, in that traditionally you would set that to 0 dp, then give it a weight, and then it will expand to fit the available space. And any size basically does the same thing. If you set 0 dp, then it will expand to fit the available area. And particularly when you're using constraints relative to other children, it will actually pack the parent appropriately.
Now, you said that this is a kind of a no for you in production. Now, is that mainly just because of CI, or is there anything else holding you back at all?
Until recently, there was a couple of other things. One was the fact that it was actually bundled into Android Studio itself. So you only got Constraint Layout installed on your machine to enable you to build with it if you had Android Studio installed, which again, for a CI server, that was a big problem, because some of them don't even have X Windows or anything installed. They're headless in that they don't have any kind of graphic environment on them. So that was a big blocker. There were ways around it. You could install them to the local Maven repo and things like that. But it was a lot of faff every time they made a new drop, which, being alphas, have been quite regular. So that was a main blocker. But in Android Studio, I think it was Alpha 5, they rolled it out into a separate library, and it's packaged very similarly to the support libraries, that they get downloaded to an M2 repository inside your SDK folder, and the build system can just find those components. And Constraint Layout has been rolled out in the same way. So just by keeping your everything up to date, all of your repos and the SDK components, keep them up to date, and you'll get the latest version of Constraint Layout. So that was a major improvement. Another thing was the performance. I mentioned earlier Wolfram's performance deep dive, but a lot of that has been addressed. The only other reason to really think long and hard about using it in production has been the noises coming out of the developers on there, and the very fact that it's still an alpha. Alpha suggests to me that it's not that the APIs aren't necessarily finalized. You can expect some stability issues. Alpha usually would suggest that to me. But from my experience, the layout itself is actually pretty stable. If there's any instability, it's more in the visual editor. And because that's not something that's user-facing, the motivations for not using Constraint Layout are actually reducing with every release. And we're not getting any information about when we're going to get a formalized 1.0 release, but it feels like it's getting closer. And you know, you can understand the development team not wanting to release anything before they're happy that it's ready and say, you know, this is stable and ready to use, but it's feeling like it's getting pretty close.
That's nice. And I would encourage listeners to maybe just try a different project and try constraint layouts, because I was also of the same opinion initially. I felt, well, let it hit stable, then I'll even consider it, because I was not too enthused by the whole concept. Being an XML sort of enthusiast, I was, well, not an XML enthusiast, but for layout editing specifically, I always felt more comfortable with meddling with the XML directly. But once I started using Constraint Layout, I started to immediately see the benefits. And I think Don alluded to this point earlier, saying your development time could possibly improve using Constraint Layouts. And I definitely feel that's the case. What you typically have to spend a quick 4 or 5 minutes thinking if you needed a relative layout, a linear layout, how you distribute weights, none of those things actually would matter as much once you get a little comfortable with constraint layouts, because it's all just pointing in most places, right? Or hopefully if the infer constraints works well enough, you don't even have to do that.
Yeah. You're always going to need to tweak things a little bit, because, a machine guessing what you intend to do is, not necessarily always that accurate, but so it helps to understand how to manually create and edit constraints, but it's not that difficult. It's not a steep learning curve.
And my thought is, give it enough time and the machines will do it better for us. So
taking over.
If you wanted to point our listeners to resources, well, let me hop in first and say your 8-part series, because I know you're a gentleman and you wouldn't bring it up on your own. So I'm going to bring it up. Go through his 8-part series. That is fantastic. That should be your starting point. But if you wanted to point listeners to other places, what would you suggest?
There's a lot of people have written some stuff on it. I've mentioned Wolfram Rittmeyer a couple of times. He wrote a really interesting post on it.
Grokking Android.
Yep, that's Grokking Android. And, that was particularly interesting for the study he did on performance. So that's a really interesting read. There's the Android Developers Backstage. They did a podcast on it, so that's worth a listen.
Who are those guys?
If you don't know who those guys are, then and that was basically with Romain, Nicola, and John, who are the main developers on there. So that's worth listening to as well.
Mm-hmm, definitely, that's a great show.
Interestingly, theirs was also episode 50. I just noticed it now.
How meta!
Yeah, I know. No, but you're right. That was a fantastic episode as well. And they talked about some of the drive and how they came about and where the direction that they want to take. So a lot of the inner stories behind Constraint Layout was revealed in that. So I think that was a very cool episode. Thank you so much, Mark. This has been amazing. I've learned so many things just talking to you about these different things. Our listeners, I'm sure, would want to reach out to you and say thank you and ask you a couple of more questions. So if they were to do that, what would be the best way they can do that?
By all means, I'm probably most active on Twitter. So my Twitter handle is Mark Allison with 2 L's. And that's probably where I hang out most and where I check most often, but also there's contact details on the blog if you go to the About page, and also you can leave comments on individual blog posts as well.
Mark, thanks a bunch. This has been great.
Yeah, it's been amazing. And if folks want to reach you, Don, how do they do that?
You can reach out to me on Twitter, and that's twitter.com/DonnFelker, or via my website, which is DonnFelker.com.
Awesome. And I'm Kaushik Gopal on Twitter, and Kaush.co is the website to reach me. And the show notes for this episode will be at fragmentedpodcast.com/episodes/50. This is our 50th episode, and we want to thank our listeners again. You have helped us through this journey, and it's been amazing. And as always, keep that feedback coming. Fragmentedcast is our Twitter handle, so you can, the good things, the bad things, what we should improve, what we can do better, what you like, what you would want to see more of. Please keep sending your feedback. Once again, we want to take this chance and thank Hired for sponsoring today's show. If you'll end up getting a job through Hired, they'll give you a $1,000 bonus. But if you use the link hired.com/fragmented, you get double that bonus. Thanks again, Hired. All right. We will catch you folks in the next episode.